In this video, I'm going to show you how to create a breadth first search in a binary search tree. So what we're going to do here is set up our breadth first search, and I'm going to do BFS, short for breadth first search, and it doesn't take any arguments. So the first step here, looking at our pseudocode, is to set Q variable to equal an empty array. So I'm going to have a Q empty array. And note that a Q works on a first in, first out basis. Next is to set a result variable equal to an empty array. So let result equal an empty array. This result will be returned to us at the end of the function. It will store all of our the entire result for us. Next is to declare a current node variable. Current node, and we're not going to assign it any value for now. Next, push root node into the queue. Okay, we have to start somewhere, so we're going to start at the very top of the tree structure, which is the root. And we're going to go ahead and push that into the queue by doing this dot root. Next, we're going to loop while the queue is not empty. So while queue dot length, then enter this block of code. While we're inside the loop, the first thing is to remove the first node in the queue, then set it to the current node. So we're going to set the current node equal to the queue dot shift. So shift allows us to remove the first item inside an array. And that first item we're going to store it inside the current node. Next, we're going to push the current node's value into the result. We're going to do result dot push current node dot value. So we are not pushing the entire node, only the value of that node. Next, if current node has a left child, then push it into the queue. So if current node dot left, then queue dot push current node dot left. If current node has a right child, then push it into the queue. So if current node has a right child, then push it into the queue. So at that point, and I made a little typo here, this is supposed to means return the result. So at this point, once the loop finishes, we're going to return the result. So right over here, we're going to return whatever's in the result. All right, and that's it. That's it for our breadth first search. Now let's go ahead and test this out. So here, I instantiated a tree and I inserted a total of 5 nodes, which builds out this tree structure here. All right, so in breadth first search, it starts at the very top and it moves down each row and goes horizontally from left to right. So initially we're starting here at the root node, and then it's going to move to the next row and go from left to right, and then go to the next row and go from left to right. That is breadth first search. So let's go ahead and test that and see what we get as a result. So we are going to call tree.bfs, and as a matter of fact, we're gonna do a console log on this. And because we're gonna use a console, let's go ahead and expand this console here. And now I'm gonna run this code here, and look what we get here. An array, which is the result with 10, 7, 12, 3, 9. And as I said, it goes from the top, so 10, and then 7, 12, and then 3 and 9. That's what we get here. So that worked out just exactly how we expected it to. All right, now let me go a little further into explaining this. All right, so what I want to do here is let me do a comment here, and I'm going to do Q. All right, so Q, we said that starts off as an empty array, and I'm going to do the result, which is an empty array to start off with. So this code works by, before the loop even starts, is we are going to push this .root. Now this .root is this right here, and it has a value of 10. So we are going to start off with the Q having a node with the value of 10. Next, it enters this loop, and then it's going to remove the first item from the queue. So it's going to remove 10, and then it's going to push that value into the result. So remove 10 from queue and then push it here into the result. Next, it asks if current node left, then push it into the queue. So this is the current node, so it's asking, does it have a left child? Yes, it does, and it's 7. So push it into the queue. Next, the same thing, but it asks, does it have a right child? So push it to the queue. All right, and so we see 10 has a right child, which is 12. So push it to the queue. At that point, it's going to restart the loop again, and it's going to again remove the first item from the queue, which is 7. Okay, so we're going to remove 7, and then again it's going to push the 7 into the result array. Next is asking, so does 7, because this is a current node right now, does it have left child? Yes, it does. It's 3. So push it into the queue. Okay. Does it have a right child? Yes, it does. We see here it has 9. So push it into the queue. All right, now it's going to go back to the loop, and it's going to remove the first item from the queue, which currently it's 12 here. So we're going to remove 12 and push it into the result. So it's now, so we currently have this as the current node. So now it's asking, does this have a left child? No, it doesn't. So continue to the next. Does it have a right child? No, it doesn't. So just continue. So we start the loop all over again, and it removes the first item, the next item in the loop, which is 3. So we're going to remove that, and then again just add it to the result, 3. So that's this right here. So now it asks, okay, so does 3 have a left child? No, it doesn't. Does it have a right child? No, it doesn't. Okay, so we're going to go back to the loop, and it goes to the last remaining element inside the queue, which is 9. So we remove it and add it to the result. So this is the current node now, and asks, does it have a left child? No, it doesn't. Does it have a right child? No, it doesn't. So at that point, we return to the start of the loop again, and at this point, the queue is empty. So this queue is linked. There's nothing inside the queue. Therefore, the loop finishes and just returns the result, which is what we get right over here. The 10, 7, 12, 3, and 9, which is 10, 7, 12, 3, and 9. And that is your breadth first search.